we'll be doing it that way. Okay, with that, Janos?
Yes, it's time to get started. Welcome everyone to this session of the IETF-DETNET Working Group at IETF116. Lou Berger and myself, Janos Farkas, co-chair this session and the working group. And many thanks to Ethan Grossman, to our secretary, to doing the secretary job. It is an IETF meeting, so it is all under the IETF Note 12, which you accepted during registration. If you are not familiar with it, then please check at your own leisure. I would like to draw attention that by participating, you acknowledge that all these contributions and everything what is said here becomes part of our permanent records and becomes public. Also, we would like to draw attention to the IETF conduct guidelines on how to behave during our meetings. Professional and courtesy behavior is expected. I guess you are all familiar with how to run these hybrid meetings, both on-site and remote. In person, on-site, please use the on-site tool and scan the QR code for the blue sheet, and also please join the queue with the on-site tool for the discussion. Also on site, please wear your masks. The rules still apply at IETF meetings. I already mentioned the blue sheets. We use the usual tools. I guess everybody is familiar with the Miteco already. And I would like to ask everybody to join note-taking. Lou also provided the link in the chat window. The link is also in the slides. We appreciate all the help capturing what has been discussed accurately. I guess you found your way here, so you know where to find the presentations and so on. I would not like to spend time on that because we have quite a busy agenda. Tuesday, there was a joint session between PALS, MPLS, and the .NET Working Group. Please check the recording if you could not participate. Here we are on Thursday at the .NET session, and our sister group, ROW, meets on Friday. So you are welcome to join that one as well if you are interested in this type of topics. As already mentioned, we have a very full agenda. So we would like to ask working group authors to focus on your changes from the last meeting, next step, plans to next step, and how to complete the draft. And please keep the timing, including discussion, as a courtesy for others, and to give floor to everyone. For the non-working group contributors, please focus on what is your addressing, what do you address out of the working group charter, for new draft summary of the technical essence, and for not so new drafts, what has been changed, what are the next steps. We will be very rigorous on the timing, and yeah, this is a full agenda. I guess next time we will ask more time at the next IETF. Status of our working group documents. We have a new RFC published on .NET bounded latency. So I would like to draw attention that we are not starting from scratch. We already have some solution for guaranteed latency. We have 3 documents with our AD, the Yang, and the OEM framework, and the MPLS OEM. And we have a draft recently adopted, the scaling requirements, which will be presented later on in this session. We have 2 slides on liaisons. We sent a response to TGPP SA2. We discussed that at the last IETF and on the list afterwards. We received a new one from ITUT GCA IMT 2020. This is not just us, but CCAMP, the MMSFCLTs received this document or liaison. So we are sending a joint response, and this is in essence update on our progress. So we will be informing them about our new RFCs. Scott is in the queue. Scott, please go ahead.
Hi, Scott Mansfield, Erickson. Whoa, that's something. Yeah, so I'm here. Obviously, I'm here this week. So if you want to talk about the subset of information that I've already sent around about the RFCs that I think should be shared, find me in the hallway and we'll get this one done. It's not due until the 18th of April, so we have some time. We can do it online. Do it through email. Thanks.
Thanks,
Thank
Scott.
you very much, Scott, and thank you for gathering all these from the different working groups. And this is the second slide. This is about the ITUT study group 13, in particular question 6. And we received a new liaison statement on their recently consented recommendations on deterministic networking work. This is for information, and a couple of background information you can find on this slide with links. Actually, IEEE 802.1 has responded to this liaison recently, and former liaisons we have exchanged or received is that we got one in the 2021 July. That was the first one, and we responded, the DETNET working group, also the 802.1 working group. I went and joined their meetings and presented it, but we have never received any response from ITUT study group 13, actually either group. So study group 13 has not responded, and further liaisons have been provided as for information on their progress on their documents. Scott, please go ahead.
Thank you, Scott Mansfield again. So I would like to respond back to the ITUT on this, but we have time because the next study group 13 meeting isn't until July. There are interim meetings, 23 interim meetings between now and July. But I think it's useful to keep the pressure up on what the work of this group is doing so that we can set up some nice guide rails for the work that comes out of study group 13. So just keep that in mind. And if there's something that you think needs to be shared, let me know and we can do that online as well. Thank you.
Scott, that's awesome. Do you feel you're able to propose a response?
If given proper guidance, if there's hot topics that you think are important, I can certainly create a response.
Okay, let's
talk
offline.
Yeah,
and try to work up
that's
something.
a wonderful way of doing it. Thank you. Thanks.
Thank you, and we will take this to the list as usual. And next slide is an update from the recent interim we had on March 7 on scaling and queuing work. David will provide more details, so I would not dive too much into it. Just a reminder, on the IPR disclosure, we follow the usual process and ways of working. Please use the list, and we can have virtual meetings, like working meetings. We will be discussing it for the scaling queuing work, and we can set up other working meetings if needed for control plane or other topics. So that's it as the intro, and let's move to the next deck, which is control plane. Shesong, can you present this one?
And while Shusong's coming up, the QR code is back. Please scan in. We need that for blue sheets. We need it for poll taking and accurate room sizing. Thank you. Shusong?
Yeah. Hi, this is Shusong. I will give some update about our work on the DETNET controller plan framework. Next slide, please. This slide is just to give a whole picture of the position of this document in the whole DETNET documents series. The first thing is that we have a .NET architecture, and inside .NET architecture, it is composed of two parts. The first one is .NET data plan, and the second one is .NET controller plan. And there is an published RFC about .NET data plan framework, and now we have a .NET controller plan framework. Based on .NET data plan framework, there is a lot of data plan extensions, solutions, and we also have .NET Young model. And based on our .NET controller plan framework, there will be potential control plan extensions for future work. And we also have some reference to the existing .NET OEM framework. Next slide, please. This slide shows what the document looks like right now. Here is the structure. In the first section, we list the .NET controller plan requirements, which aligns with the .NET data plan framework. And in the following three sections, we split it into three parts, which is control plan and management plan. In the control plan, we have defined three types of control plan architecture, and also we give some .NET control plan considerations for a list of .NET mechanisms. And also we give an overview for .NET management plan. In this just updated version, thanks for the contribution from Carlos, we have added a new section about multi-domain aspects. This section is added to support the collaborations of multiple controller plan functions among different .NET domains. And there is a gap analysis sections before. We think maybe we can consider to remove this section because it can be left to the potential control plan protocol extensions, not in this document. Next slide, please. Actually, this slide has been presented in last IETF. There is no feedback yet, but we think it's a very simple and useful update because in the previous slides, I have mentioned that we have a section about .NET control plan considerations for .NET functions. Now it's just as a list. We list 4 functions: explicit, pass, resource reservation, replication, elimination, ordering function, and also data plan specification considerations. What we're trying to do now is to make it more logical. Maybe we should add a very simple figure as showed in the picture to make it a logical process about the whole control plan, including resource collection, pass calculation, pass allocation, and the resource reservation. But the contents will be almost the same. Yeah, and this is another proposed update. It's also very simple. We have then a control plan, we have then a management plan, and here we just give a consideration for how to give a connection between this plan. Maybe when the measurement result is not so satisfied, there will be an update about the resource reservation. Yeah, it's also open to further work. It's just a guidance. Next slide, please. Yeah, we think the .NET controller plan framework is important in the whole .NET structure, and the contents of the document is very stable. We think if the working group agree with the update we have proposed, maybe it is ready for next version, and we can have a working group last call. Yeah.
You have Kwan and Q?
Yeah.
Yeah, I'm Zhuan Xiong from CT. I have 2 suggestions. Please back to the slide 2.
Can you go to slide 2, Janosch?
Yeah. So, last slide.
Next?
Yeah, last.
Next slide, please.
Okay. The first one is I agree to add the multi-domain aspect, but maybe it is better to put this part into the controller section because I think this is more like controller plane enhancement. So
which section you mean?
Yeah, the controller and the management. Your draft has divided into controller section and the management section. So
yeah, I understand. Yeah, you think it should belongs to the .NET control plan?
Yeah.
You mean section 4 or section 3?
Yeah, section 3.
Okay. Yeah, we will consider. We will maybe discuss with Carlos, because Carlos has also suggested to make it inside the existing section or have a separate section. We think maybe it's more easy for people to find it if it has an independent section. But you raise this, we will discuss with Carlos and we will give feedback to you. Okay,
Yeah,
thank
yeah.
you. Thank you for the suggestion.
And another comment is, please back to the last slide. Yes, okay. I agree to enhance the controller plane for the enhanced DETNET, but from the structure, I think it's more like a controllized control plane. We need to consider the distributed control plane or the hybrid control plane. So, for example, you have pass allocation button has no pass request. So I think we should do some more discussion on the mailing list. And another question is the pass establishment and the reservation, the resource reservation. They are. I think they can be implemented separately. So there are the two questions about this enhancement.
Yeah, I understand your consideration, because actually in the control plan architecture, we have covered the 3 cases.
Yes.
It's centralized, hybrid, and also distributed. The figure is just, to show a centralized case, but actually the logical process of the path establishment, the path calculation, actually the logical process won't change. What we think is that just reorganize the whole functions in a logical way, but that won't affect how to do the control plan, whether it is distributed or with signaling.
Yeah, maybe we should list all the models and then see what is common in the structure to add which one to the section.
Yeah. Okay.
Yeah, we can do more discussion on the mailing list.
Sure.
Yeah, great discussion. Thank you for the comments. I look forward to reading on the list and try to get the refined text.
Yeah.
Sure.
I think the discussion also highlights that now's a great time for others in the working group to go look at the document and bring their comments forward. I think we're seeing that there's more work to be done, but hopefully we're getting closer. So thank you very much.
Almost there. Thank you.
Thank you.
David.
Okay, next slide, please. All right, so brief report. We had interim meeting on March 7th. The slides have been posted to the list. In addition to the controller plane draft, this would also be a good time to read and think about updates to the scaling requirements draft. The rest of the slides I'm not going to go through discuss plans for the data plane enhancement. We're intending to proceed with the plan proposed in those slides, including, I believe, the first meeting on April 11th, which was announced back in the interim meeting. Please watch the list for details. While I'm here, I want to thank Shisong for organizing a side meeting yesterday. Some interesting suggestions were discussed there. One is that it might not be a good idea to leave the scaling requirements draft open independently. We do need to proceed from requirements to solutions, so we ought to impose some sort of a cutoff, at which point we will probably start using the requirements draft in roughly its form at that time. I think there was a request that we find some way to facilitate longer presentations of potential solutions, because the 10-minute slots that we can allocate in the meetings just aren't enough to really go into the solutions in details. And finally, a suggestion that in addition to the requirements in the requirements draft, we ought to pay some attention to evaluation criteria that we would use to choose among solutions when we have multiple choices. And I think that's an important suggestion about which there will be further consideration and discussion. I'm not prepared to make an announcement as to how we're going to do it, because quite frankly, I don't know right now. Any comments or questions?
Doesn't look like it. Please continue.
All right, I'm going to declare victory because the rest of the slides here were shown at the interim meeting. I don't think I really need to review them, and I'll get you ahead of schedule.
Great. Do you mind just bringing up the schedule slide again?
One more. Bingo.
Perfect. Thank you. So just to make sure everyone is on the same page, the plan is that we're going to have a series of meetings to go into details of the proposals and try to work through coming to some, I don't want to use the word consensus because these aren't formal meetings, but some directions to recommend to the working group. And the information that comes out of these meetings is going to be brought to the list and discussed in the working group, and on the list is where we'll make the consensus decisions. The intent is also that these meetings are going to be recorded, so if you are unable to make the meeting, you can still get a recording and see that recording. Right now, the plan is WebEx. If that doesn't work well, we'll try to move over to Meet Echo. We were successful in testing the audio recording capability from the last WebEx, that informal meeting. I myself had a conflicting meeting because it's the last minute schedule, so I'm planning to review it. I haven't had a chance yet. While the discussion was captured, it actually recorded like for 4 hours. So it's a little bit suboptimal, so we'll see how it goes, but this is what we're going to try. If we find that it's not working well, we will make other adjustments, maybe over to Meet Echo. Please keep the chairs in the loop if you are seeing that the process is not working, or if you feel like telling us it's working great, we always like to hear that too. David, thanks so much for taking the lead on this. You're our tech advisor, and you're playing an important role. Really appreciate it. I think we're ready to move on to the next one. Peng?
Peng from China Mobile, and I'll give an introduce of the requirements for scaling the network. Next, please. So it's 0.1 version updated from the 0.0 and address the comments from during the adoption call and recently, and we also have the discussion in the interim meeting and also had the side meeting in Wednesday. So thanks to David, Balas, Kira, and Dove gave the suggestions and the comments. There are so many useful comments, so I list the link here and you can check it. And first is the rename of the document. We changed it from the large scale to scaling. So in the new version, we didn't give a definition for the scaling than that because it's not a scaling than that. So and we also changed the abstract for the large variation in latency and among hops. Next, please. So here's a summary of major comments and changes. I didn't list the minor comments and the changes, and you can see the difference from the two versions of it, and some of them have been addressed, including the name and the introduction. We add a bullet, 5 new bullet related to flow fluctuation, and in the section 3.1.4, we change the title to provide a mechanism not requiring synchronization to make it not really indicate the method. And for section 3.4, we moved a different level of the DETNET service demand to section 3.7. It is now about the aggregation. And there's a new subsection of section 3.5 to address flow fluctuation. And for the section 3.7, we add some explanations for different situations of the queuing mechanisms. And there's a comment remind to be addressed is for the section 4. It is not one-to-one mapping, so that is expected to be one-to-one mapping. So we are just wait for a better solution of it. So next, please. And here's the key attributes in the introduction, and also give the changes in red about the section, about the second one and the fourth one, and yes, so it lists the changes from the before, and we think it might be more suitable to give the abstract of the scaling DETNET. So next, please. And here's the new version of the technical requirement in section 3, and we changed the fourth point in requirement 1 and change the requirement 4, some text of it, and also change the name, add a new requirement of requirement 5, and for requirement 7 we give some move some text here and give some explanations for the two cases. One is support configuration of multiple queuing mechanisms, and another one is support queuing mechanisms which over crossing multi-domains. But now we think that the name of section of the requirement 7 might be not suitable, and we are going to rename it because the requirement 1 to 6 are also the requirement for queuing mechanisms. So but none of them are listed explicit with the name of queuing mechanisms. So next, please.
You have someone in queue. Do you want to take it now or later? Greg would like to ask a question. Do you want to do it now
okay,
or
sure,
after?
Sure, please.
Hi, Greg Mirsky, Ericsson. So as discussed, I can imagine why time synchronization might not be critical for a data plane itself. There are different proposals. But what I wonder is how the one-way time delay can be reliably measured without clock synchronization. I'm not aware of any method that can reliably, accurately measure time delay without clock synchronizations. Thank you.
Yeah, thanks. So what's your suggestion for the requirement?
Can I make a suggestion? So this is, remember, this is requirements, and what you've just said is about implementation.
No, it's a requirement.
It's a derived requirement. It's about how to implement something. It's not a first level requirement.
Okay, but since the requirement to have to be able to measure accurately one-way delay, then
Yeah, sure, exactly. I think we had one-way delay measurement draft before, but in fact, we think we need to get more consensus if this is in need to be considered in the requirement.
We should probably take it to the list.
Okay,
We only have
let's take it
4
to the
minutes, but I think that's a great discussion point, and the question is where to capture it, because either way, we're going to have to do it. I see that David Black is in the queue.
Greg, I'd suggest separating measuring from achieving. It is possible to achieve it without having to do the measurement as part of the achievement. If you know what every piece is and you know the sum of the pieces, you know what you know what the total is. There's at least one of the candidate solutions that's pursuing roughly this approach. Although I understand that to confirm that it works, you actually need to measure that it works.
let's
Yeah,
let him, wait,
no, I'll-
Greg,
I'll-
Greg, let's let him get through his slides. And
okay.
if there's time left, we'll come back to it.
Okay. I will have to write it down.
So Greg, join the queue. You'll be first in line if there's time.
Well, thank you. So it's mapping of the key attributes to the technical requirement. I will won't really go through them one by one, but you can check it by yourself by your side. Yes, next please. So here's the problem of section 4. The requirement 1 is for the support aggregate flow identification. We think it is needed to for the prefix or wait cards to indicate the aggregation function. And the second one is about the metadata of the queuing mechanisms proposed. So we think might be for the new queuing mechanism, we should also add some new information in the data plan, but should also consider the efficiency issues. But for the last two, they are not really inferred from the section 3. So now we are going to remove it unless we could enhance section 3. So we can go next slide, please. So here's the next step. Yes, so much for the next step. Because we have the discussions recently, and the first one, we might try to enhance section 3, but if not, we will remove the last 2 sections in section 4. And during the interim, we think we should classify or sort the technical requirement to find out the priority. I think because we think our work is also work with solution draft, and we had so many solution draft. So we're trying to give a simple classify the one is for the scaling network and another for the scaling the flows. And for the requirement 7, we'll, just as I said, we will go to rename it. And here's some comments from the interim, give some new aspects to be considered. And I also hope that the authors of the solution draft could really introduce which requirements now your solution has met it. So that's all. Thanks.
Okay, thank you. Thanks to David, we actually are running a couple of minutes ahead. And since this is a working group document and an important discussion, Greg, do you want to come back to the mic? And okay.
Just quick note, we also have the document now on GitHub. So if people who want to, contribute, have questions or so, feel that's a better way to have discussions about individual points like it's done in many other working groups, please feel free to open issues. Obviously, it would be good to also leave notes on the mailing list when you do so. Yeah,
keep in mind, GitHub is great, but the place for discussions in this group is the mailing list. Where we definitely want to take advantage of GitHub and pull requests to help expedite document, but the place for consensus building is the list. Even side discussions are great. Just remember, consensus is here. Thank you.
Thank you.
Thank you. Shusong.
Hi, this is Xuesong. Actually, I will introduce some sleeping work, DETNET topology Yang. This is already a working group document, but it has been in a sleeping status for a while. So I will give some introduction about why we want to make it alive now. Actually, we have already, has already been a DETNET Yang model document. It has already covers the DETNET service, DETNET flow configuration, and DETNET functions configurations along the path. We have another working group document called DETNET topology Yang, which covers the topology-based DETNET capability and also topology-based DETNET requirements allocation. The first DETNET Yang model is quite mature now, and it is waiting for RFC publication. And we think it is a very good timing to discuss the DETNET topology Yang. And also another very important motivation is like just as Janusz has already discussed, there is a liaison from 3GPP, and they also discuss about DETNET stuff. And there is a request from 3GPP, maybe is in the scope of this document. We will have further discussion in our presentation. Next slide, please. The requirements of the DETNET topology YANG is like it is an augmentation of the existing DETNET traffic engineering YANG model, and the following attributes are requested, including bandwidth related attributes, buffer queue management related attributes, and packet replication, elimination, ordering functions capability, and also some attributes about delay. The above attributes are categorized into 3 types based on RFC 87, 90, 95, including node attributes, link attributes, and LTP attributes. Next slide, please. Here is the DETNET node attributes. We want to introduce the maximum, minimum, and maximum minimum DETNET packet processing delay, and also the maximum DETNET processing delay variation. This is based on the delay discussion defined in RFC 9320, and there is a very detailed classification of per hop delay, and the attributes we define here is has corresponded to the existing latency discussion. Next slide, please. And we also want to cover DETNET link attributes. It includes link delay, maximum DETNET reservable bandwidth, and reserved available bandwidth. It is also related to the link, the delay discussion, as I have mentioned above. Next slide, please. Also in DETNET LTP, we want to define the capability of DETNET for packet ordering, replication, and elimination. Maybe also include the maximum number of out-of-order packets. Next slide, please. Also, there is a lot of queuing discussions that is happening in DETNET working group. We think maybe it is also a good timing to also include it in this document, because the queuing mechanisms is also very important as topology attributes. Next slide, please. I want to invite Tianji to introduce this part. He's also deeply involved in the 3GPP discussion. So, please.
Tianji from China Mobile. Xuesong, thank you. And this is regarding a real project that being at 95% completion in 3GPP SA2 working group. For this project, it's basically to have the 5G system as a logical DETNET YANG node. I think at the beginning, I forget the name, but someone mentioned about a liaison from 3GPP sent to IETF on this one, and happily IETF has already replied on this one. So here, before I delve into that one, I will give a brief, just a description about this one. So basically, you can consider 5G system as a black box or logical transparent node, though it has a lot of complicated network functions and components within the black box. On the left side picture is the work that being stabilized since release 16, v16.15.0, being in the red font. So on in that picture, toward the left side is like a terminal, or we call the UE in 3GPP. Some nodes or some devices can be connected through the left side of that picture, and toward like a cloud is a domain. You can count like a TSN domains. And then this is connected from the UPF, or the terminology or nomenclature in 5G system. So beyond it is like a TSN bridge that is connected the left side TSN with the right side TSN. And then the right picture is just like the granularity that being defined in 5G as DETNET logical node project. So here it's just talk about the only architecture assumption about considering DETNET forwarding sublayer and IP forwarding, and then some granularity defined. If you look at the right side picture, and then you can see within the black box the logical node, and then DETNET node ID will depend on the UPF. So within the 5G system, you may have more than one UPF nodes. So to make it very simple, just consider the 5G system as a transparent logical node and join in the DETNET domain. Next one. Next.
Janos is doing it.
Oh, sorry about that. Okay, sure. So here, this is regarding the issue that should be addressed. In the 5G project, it has two key issues to be addressed. Remember, I said it's already 95% completion. So to make it simple, the first issue is to have 5G logical node as a DETNET logical node to offering information toward the DETNET controller. And then the second key issue is the other way around. So basically to ask the DETNET controller to send like a flow attribute, flow requirements toward the DETNET, the 5GS DETNET, but this is on the expectation of per logical node. So I give one, hold on, Dean, let me finish and then we can discuss. Okay, so here I give one or two examples. Like one is like a max latency mapping, that is a DETNET flow requirement. And then so far in 5G document, it's going to be in the standard within a couple of days already. So it's going to map to the PDB, the packet delay budget that is within the 5G system as a single logical node. Well, the flow latency, the max latency actually is end-to-end. So because there's no such functionality at this moment, so the 5G, the project just take it is not just approximate, but it's incorrect actually. There are some other things also. And then because of this, and because of the liaison I mentioned at the beginning, liaison coming from 3GPP to IETF and then reply, on the reply, it's about 4 points. The first, no, there's no such a document in IETF to handle the issue. Second, the first one is yes, it's something can be done. Second, there are no such work in the DETNET group right now. And then third, there is no corresponding work in other IETF working groups. Fourth, welcome contributions. There are something and welcome contributions from our people, our contributors. But happily, after the meeting at the end of last month in Athens from the 3GPP, I happened to find this document, this working group document. So I talked to Xuesheng about the things and went through the document and happily found all kind of applicable attributes defined in this draft. And then that will be applicable to the 5G requirements, 5G DETNET project requirement. So because of this, and also today in the first presentation, there is the one IETF draft that's going to be RFC soon. That one is being referenced in 5G spec. So far, even if it's not RFC yet, but it's being referenced as authoritative or authentic information. So because this one is already working group document, though it's dormant for a couple of years, but given the current situation and given the practical requirement, remember this 95% completion, and will be complete either by next month or toward the end of May. So we are asking for the reactivation of this draft. Thank you.
Great, appreciate it. We seem to have we've lost Janos, so I'm going to try to
Dean, right?
reshare the slides. Did you have a final slide, or was that the final slide?
You want to take a question, or is it okay?
No, I'm asking you a question. Do you have any more slides?
No, I do not.
Okay, so if you saw the questions before was, what is the next step? So you didn't say what the next step is.
Okay.
Sorry, Lou, maybe I have, there is an updated version of the slides, and there is a last page. It is talking about the proposal. The first thing is that we want to, we want to activate it. And another one is that maybe we are trying to prepare a new document to provide guidance about how to use this young model to inside the 5G system, and just to ask the working group feedback about this proposal.
Great. It's good to see the document coming back to life. I don't know, all it takes to reactivate is publish and get the discussion going again on the list.
Okay, that will be perfect.
Okay, great. Thanks. John?
Yes, Dejan Bogdanovic. So there is the RC 8345 that is a network topology young model. So why not use that as a base and to augment it with the DETNET specificities?
Can I answer the question?
Sure.
Yeah. Actually, this is the augmentation of the existing TE young model, and inside the TE young model there is a delay defined, but it is link delay. But inside that one group, what we are trying to do is that we also give a upper bound of the queuing delay and other processing delay
Those
inside
are all
the model.
attributes of existing links.
Then there are quite a few requirement parameters that are going to be required from the 5G system, not just the delay, like even like the max packet per interval, mean packet, or GFBR, all kind of things. So it's not just the delay. Delay is one of. So
Dan, this is building on top of what's been going on with TEAS, the Traffic Engineering and Architecture group, and what they have with topology. So it is building on other work. It's not a new piece of work. Okay, it looks like he's gone off to a side discussion. We're going to move on to the next.
okay, sure. Thank you.
Jinyu?
Just very briefly, sorry, I think actually the TEAS work is based off 8345. So basically through the transitive closure, 83, it should derive from 8345. You may want to check and perhaps include it in the references.
Hello, I'm Jinu Zhang. I'm going to introduce about the ADN framework for large-scale networks. Thank you.
Okay. I'll just point out that at this point, we're shifting off of working group documents. We're going to try to hold discussion at each slot to 8 minutes. There's a lot happening. So we're going to try to be fair to the ones at the end. We're going to try really hard on the time.
Okay.
And so with that, I'm starting the clock. And thank you.
Okay, I'll do my best. Next slide, please. Actually, the pages are not so many, but it is very hard for me to make you understand all the stuff in this slide. So I will just introduce you, and you can read the slide while I'm talking. That would be better. So this document is divided into two parts. The first one is about the latency guarantee. The second one is about the jitter guarantee, okay? And the latency guarantee part has also divided into two parts. The first one is using the regulator, just like the ATS and IEEPTS and test group. The second part is using the fair queuing technology that I'm going to introduce today. So what I'm talking today is just a small part of the whole document. So I recommend you to read all the document. So the major revision we have in this version 2 is introducing two new technologies. The framework itself has been given. The framework is listed in 3 bullets above. It is how to make the finish time, so-called finish time, that is the service order given to the packets in the core node without flow state maintenance. Here in the revision 2, we have introduced DHP value that we can call a delay factor value, which is given like that. L max divided by R, large R, plus L divided by R. You can see the definitions of the symbols over there. And actually that delay factor value has a special name, so-called service latency, but I will not introduce that today. And if you use that value, the end-to-end latency of the flow is bounded like that. Yeah, there are so many parameters, but all of them are specific to the flows, except the Lmax and large R. Lmax is the maximum packet value over all the flows in the node, and large R is the link capacity. So those two values we cannot control. But all the others you can see over there is flow specific. So the important thing here is you can control the end-to-end latency bound by requesting more service rate and so on. So it has a great advantage, but it has one implementation restriction. That is, it has to use sorted queue. So next slide, please. Yeah. So we are introducing the second solution, with which you can use FIFO queues. Here, the key point is that you can assume there is an assumption that there are a finite number of flow types. The flow type is defined by the L, the maximum packet length in the flow, and the R, the service rate. If these two are the same, we call the flows are the same type. So we assign queues for the similar types of flows, and then the queues can be used in the FIFO manner. Next slide, please. So the second solution, we don't have the mathematical latency guarantee bound, but anyway, we have simulated. This is a simulation setup. Yeah, you can take a look. Maximum hop count is 7. The link capacity 1 gigabps. So it is not a very big network, just a medium-sized network, I would say. Next slide, please. This is the simulation result for the solution 1, that is using the sorted queue, such as push in first out. It has the bounded latency, mathematical bounded latency, which is given with the red dotted line. And the simulation shows that our so-called C score, which stands for work conserving stateless core fair queuing, shows much less bound. Actually, those box plot is the statistics of the maximum observed end-to-end latency, not just delay or latency. It is we have run the simulation 100 times, and during one simulation we observed just 1 point, that is the maximum latency, end-to-end latency. Those 100 points forms the box plot. So it is the statistics of the maximum latency. Yeah. We have compared with ATS, FIFO, and DRR. Those are very well-known schedulers. ATS in this case is just the interleaved regulator plus FIFO. And DRR using per flow queue. So it is, you can say, more complex than our approach. But somehow we have managed a very good performance. Next slide, please. And even in the second solution using FIFO, the end-to-end latency bound statistics is not distinguishable with the first solution with the pushing first out. Yeah, okay, next slide, please. So how good is the end-to-end latency shown? We have a simple simulation in mind with the ideal slotted scheduler. In here, the link capacity 1 gigabps, and everything is fitted into a slot. So the flow, there are 100 flows with the 10 megabps service rate. So they all fill up the link capacity. And in such an ideal case, The end-to-end latency bound is almost the same with the syscore just shown. It has the very good end-to-end latency performance with all the robustness, scalability, and superior statistical performance. Next slide, please. Yeah, you can read the summary. So the next step, we would like to finish the requirements document as fast as we could, and then we will focus more on the specific solution. For example, syscore in a more formal standard document. Thank you.
All right, thank you very much. We don't have time for a question. If you could take the list. These next series of queuing documents are going to be subject of the offline discussions. And you could have, rather than this little 8-minute slot, maybe you'll have a 45-minute slot and really go into detail. Very interesting.
Okay, thank you.
Okay, next up is Torlis.
Okay, let's try to beat the 8-minute clock. So this is just 3 changes since 01 that we showed in London. Next slide. Right, so the first change was based on the review by David Black that we did in London, and that was about, the specification of the mechanism to be too much descriptive, instructive, rather what seemed to be necessary insofar as using a queue to enqueue in a slot and then to dequeue from it. And so when I revisited that again, obviously for TCQF, it doesn't matter how packets are released from a slot and forwarded to the next slot, right? So they can be randomly misordered on every hop, and the overall latency and jitter in the end will still stay the same. But as soon as we have more than one packet from a single flow in a single slot, then reordering would obviously be undesirable. And obviously it would also be undesirable to have another header to do reordering at the end. So I think at this point in time, the proposal is, and that's what in O2, that we want to maintain for every packets that come in from the same incoming interface going out into the same cycle, the order should be maintained. That's now shown in the pseudocode, but the timing with which packets from different incoming interface in the same slot are sent out, or if things are sent out as fast as possible within the slot or spread around, that's left free, and I have described that in the text. Next slide. Right, and this is kind of the way that the pseudocode looks right now. So I was kind of trying to abstract for all packets, and then there is just a queue for all the packets for a particular cycle from the same incoming interface. But other than that, it's scheduled to send packets before next cycle starts. So that's the attempt to express that behavior. And I'm not sure if it's the best expression, but at least it captures now the goal that we have. And yes, please provide feedback and comment about any of this. Next slide. Right, so Lou Berger's feedback was, how about the controller plane? So now there is another consideration section, the considerations section for controller plane. And obviously it's TCQF, like I guess all of our algorithms are applicable to a centralized control plane, admission controller, path computation engine, and of course simple admission control policies as outlined in Ingress Shaper, maximum number of bits. So that's, I think, very easy to see. When you give a flow a certain number of bits in every cycle, you can get more efficiency in the same way as in the TSN solutions that are based on the same principles if you allocate fewer bits, but then you have to do a more network-wide computation in the centralized controller, which is also one of the great ways why you may want to have a centralized controller. Now, for those of us who love the distributed models like RSVP-TE as a controller plane, that will work equally well. Except obviously that one has to discuss whether you want to have a distributed control plane when you are trying to be stateless. But so what I was writing there is that The statelessness in the forwarding plane at 100 gigabit is a completely different goal than statelessness at the control plane for the number of flows. So the combination may still be very valuable. Next slide. Okay, so and then I finally found the deployment report of the Chinese university network deployment of the proof of concept, which was built on 100 gigabit routers with FPGA that was validated in 2020 across that CENI research network in China. I've co-authors have extracted 2 slides, and we didn't get everything translated to English. Sorry for the short time. Next slide. So here is one test done in the Shanghai Nanjing region. So 4 routers, and we're sending packets around that topology back to the original router where the test engine was injecting and then removing the packets and measuring them. Each of the hops in doing TCQF. Next slide. And so here's the comparison, and unfortunately, that's the stuff that's still Chinese characters. So the left column is showing for an ever larger number of background flows that are not TCQF, their jitter. So that dark column starting with 83 down to 2304, that is the jitter incurred for the background flows, and you can also see that on the left-hand side, the gray stuff is the latency, and therefore you can see the large jitter of these background flows, and then the boring orange line that's almost invisible and is showing, you know, a per hop jitter of 29 microseconds. That's the TCQF traffic. Well, and that's pretty much it. Thank you.
Great, thank you. Again, more discussion to come in the open meetings. Thanks to Google Translate, I could actually read what you wrote, so it's great. Thank you.
We'll try to do it better.
No, it's great. Thank you for the data. Okay, so moving on, Shafu. Now, I think this is the one where we had multiple versions. Just as a heads up, we have multiple versions of your slide, and MeetEcho isn't telling us which version we're sending, so I'm hoping this is the right version. If it's not, I apologize. I'm also going to give you control so you can advance the slides on your own. So you should have a bar on the bottom so you can advance. Thank you. Please go ahead.
Okay, thank you. Hi everyone, this is Xiao from GT. I will introduce the data-based forwarding mechanism. Okay, this version mainly contains 5 updates. The first is the buffer size and the scalability conditions for leaky bucket and the concept of delay source. And the third is the conditions for the untimed mode. And the fourth is the admission control and the ingress. Then the last is the overpollution analysis. Again, the motivations for the motivations of this proposal is to fund the potential queue mechanism that match large scaling requirements. As we know, there are many existing scheduling algorithms such as TSN, CBS, ATS, CCAF, and widely deployed strict priority algorithm and traditional EDF. But they cannot be directly used in IPMPS to achieve deterministic queues. So this proposal is to discuss variants of EDF with enhanced latency compensation. This is a simple overview for the mechanism. Each deadline queue has a countdown time attribute that is decreased by rotation time interval and has a authorization time attribute that is sending duration. Then a packet with allowable current delay computed by planned residence time and accumulated residence duration will put to deadline queue meeting the conditions. So for the first update, the countdown time of each queue is dynamically changed, so it is not bound to a fixed delay level. It will actually store all levels of traffic during its countdown deployment process, considering the stability condition that the sum of bandwidths of all levels is less than or equal to the service rate. Then buffer size is simply designed to service rate multiple by authorization time. According to the NIC bucket constraint function shown later, we will see the bus resource of any level must be less than the full one. However, the bus resource of each level will be more small if the bandwidth of other higher priority level cannot be negligible. When the concurrent bursts of all levels are received during the period of maximum level, all bursts can be sent one by one before the deadline. For the second update, if the arrival constraint function is NIC bucket, the conditions is like the following, especially when the bandwidth of each level is negligible because of the burst interval is too large, and the burst size is limited, then the maximum burst resource of each level may reach the full value. However, generally, the bandwidth of some levels cannot be negligible. That causes the burst resource of the low priority level cannot reach the full one. The delay resource is the enhancement of the traditional bandwidth resource and contains the burst resource and the bandwidth resource for each level. For the third update, at the current phase, we found that the anthem mode applied and the transit node does not make sense because it did not the packet exceed its deadline. There are two extreme cases for the anthem mode. One case is that the sum of all levels burst size is less than the full value. In this case, the exceeding value is 180. Another extreme case is that each level's burst size reached the full value. In this case, the exceeding value is from 180 to the duration of the maximum level. However, anthem mode is useful when applied and egress node to avoid jitter. With the help of latency compensation, a packet can be held until its deadline. For all packets sent to the same outgoing interface attached to the client equipment, we assume that they belong to the same level and obtains an exceeding delay of no more than 180. So for the admission control and ingress, the deadline queue mechanism must be used with the resource reservation and admission control and ingress. In general, the admission control is based on the NIC bucket place and incoming port. The bucket depth should be set according to the reserved burst resource, and the bucket rate should be set according to the reserved bandwidth resource. Based on the resource reservation and the admission control for each pass that passes through the same observed link of a transit node. The concurrent arrival traffic will meet the scalability condition. The microburst traffic from a specific path will be punished and get a large allowable queuing delay, so that not exceeding the arrival constraint function. The latency compensation exactly plays the role of reshaping and the transit nodes.
Please wrap up. You're out of time.
Oh, okay, half of my minutes, I will quick. For overpollution generally happens at the case that a service flow has a large burst size. However, the service flow may also have a large burst interval and in fact require a small bandwidth. The resource mode of the non-queuing mechanism separated the burst resource and bandwidth resource to avoid overpollution issues. For example, in the extreme cases, even the allocated burst resource of a specific level reached full value. It does not mean that we have to send the full traffic on every window of AT. In fact, other windows of AT can send the burst from other levels. So this page is for the evaluation of this mechanism match the degree of the requirements. We can take a look at it. Okay, thank you.
Thank you very much. Again, we look forward to hearing more of this in one of the side meetings. Please work with David Black to schedule that. Shusong, you're up next. Thank you very much, the remote presenter.
Thank you.
Sorry, having a little trouble getting the slides back.
Hi, this is Xue Song. I will introduce our work about enhanced DETNET data plan. I will showing the question also in the presentation. We haven't get a clear idea about the position of this work in the working group. Maybe we can have further discussion after the presentation. Next slide, please. Considering that the working group has already rechartered and there is a new terminology bringing the scope, DETNET enhancement, in my understanding, maybe it is not so precise. We have already defined the DETNET concept in DETNET architecture, and in the architecture document, it is supposed to reuse the existing IETF and IEEE mechanisms to provide boundary latency, and also we have just published RFC to give a guidance to how to compute the end-to-end latency with the existing technologies. There are a lot of existing queuing mechanisms, including the preemption, time-aware shaper, or other any types of queuing mechanisms. And now in the forwarding sublayer, we want to provide some enhanced DETNET. We will define new layer 3 mechanisms for resource allocation, for boundary latency, and zero congestion loss to satisfy new requirement, just as Peng has introduced in the scaling document, which has already been working group adopted. Next slide, please. So the problem will be how to satisfy the boundary latency requirement in the scope of DETNET enhancement. The basic idea is that for boundary latency, there are 3 necessary parts. The first one is queuing, shaping, scheduling mechanisms. There are a lot of documents. Actually, the previous 3 presentations are all I think, in the scope of this part. And the second part is the encapsulation. We should have some data plan encapsulation in the packets to support all these underlying mechanisms. And the third part is the resource reservation, which belong to the controller plan. Maybe that requires further work in working group when it is the time. Next slide, please. What we are trying to do is to find the gap about the DETNET enhancement data plan encapsulation. Actually, as I have mentioned, there are a lot of queuing mechanisms in the existing work in IEEE 802.1, also in IETF, and also some new work that has been discussed in DETNET working group. And we summarize all these queuing mechanisms. We find that if we want to give some support in the data plan of the packet, all we need will be classified into three encapsulation types. The first one is the priority. The second one is the flow or flow aggregation identification. And the third one is time information. What we have found is that priority, flow or flow aggregation identification that have already been defined many times, maybe not many times in existing IETF work. So maybe the missing part will be the time information in their three encapsulation. Next slide, please. So based on this observation, if the time information is the missing part of the DETNET enhancement data plan encapsulation, there will be some initial solution proposals for different types of DETNET data plan, maybe as the some argument to the existing DETNET data plan work. For example, in IPv6, IPv4 header, new DSCP value or new DSCP meaning could be introduced for presenting time information. And in MPS, new EXP value of MPS label could be introduced to cover the time information. And maybe in IPv6 with extension header, new options of DOH or hop by hop could be defined to carry time information. And for SR-MPS, SRv6, which we can introduce meaning for seed, we can introduce the time-aware seed that can be used for time information. Next slide, please. We think, sorry, there is no proposal yet, but we think this is the right direction of discussion, the encapsulation issues. But we, all these contents I have put into the main list to find the proper room in the existing discussion of the working group. We just maybe need more comments from working group and also from chairs about how to, push this work and how to find, the good way to discuss with others. Yeah.
Okay, thank you. We do have a minute or two for comment. Thank you for leaving time for that, for discussion.
Yeah.
Kwan?
Yeah. I'm Chen Sheng from CT. I saw you mentioned the flow aggregation and the priority and the time information, but then you, as you said, you think the enhancement is just for the forwarding sublayer, but the flow aggregation is the surface sublayer. So what's the relationship between the priority, time information, and the flow aggregation?
Actually, the flow, can you go to the previous slide? Janusz, can you go to the previous slide? Thank you. Yeah. Actually, the flow aggregation identification here is a general concept, not only the flow label defined in the existing DETNET documents to do the replication elimination ordering function. It is, for example, in the IPv4, IPv6 data plan document, the flow identification, for example, 5 tuples can be used for forwarding sublayer 2. So it's a general concept, not just for the flow label that has already been defined or stream label.
Okay, thank you. So I think we should do more discussion about the forwarding sublayer enhancement, or we may include the service sublayer enhancement. Thank you.
Thank you. I think actually I have showed in the previous slides, I think the boundary latency belongs to the forwarding sublayer based on the architecture document. So I think the answer is I think sure. It's yes, it's a forwarding sublayer.
I'm not sure, so I think we should do some discussion.
Yeah. Okay.
Hi, Greg Mursky Erickson. Can we please go to the next slide? Because that's where I have a couple notes and questions. Yes. Okay. One, I would encourage you to use current MPLS terminology There are many people who don't know what EXP is because it's been probably like 15 years since it's been called as a TC field,
Oh,
traffic
thank you
class.
for pointing this out. Yeah,
Yes.
thank you.
Um,
Thank you, thank you. I'm not an expert of MPS. I have
No,
to apologize for
that's
this.
fine.
Yeah.
Some old timers can probably recall that it was experimental, but it's been quite a while called traffic class. The next thing is that I have a question about what's your intention for the aware seed to carry their credit information, or just to say that this is something that, because if you're looking to carry their value associated, so basically how much it's credited, I would encourage you, at least in MPLS, to look at MPLS network action work. So there is to extend MPLS data plane to be able to carry ancillary data in a label stack.
Well, that is helpful. I think it's good suggestion. It's, just a very initial proposal about
No,
what should be carried.
Right, but
Yeah.
When you understand what you want to achieve,
Yeah.
so you can find the right tools. And actually might be very timely work on MPLS label stack architecture that will suit your needs. Thank you.
Thank you for the comments. I'm sorry. I'm going to mispronounce your name, so I'm not going to try. I'm sorry. If you can take your comment to the list, that'd be appreciated. Okay.
Yeah, I'm Chuan Sheng from ZT. On behalf of the co-authors to present the data fields and the encapsulation for enhanced DETNET. Next slide, please. So this is a recap of the queuing-based enhancement. And for the beginning, we began under September 2021 in the DETNET internal meeting to propose to retrieve and consent for the queuing-based topic. And then we proposed the common data for IPv6 to in the data plane. So then from now, as far we draw out the common data field to place that part into the data common data field. We propose a new data plane draft to propose the common data field, and then we update the MPLs IPv6 and propose a new SRH draft. And next slide, please. So this is our understanding of the requirements and the gap analysis. So I think the primary goals for the enhanced DETNET is to provide the differentiate levels over the DETNET surface. And from the characteristics over the scaling DETNET network is scaling networks and the scaling flows. This is the current existing networks. So from the goals plus the characteristics, and then we analyze the gap over the existing data plane. And one of them is we cannot guarantee the bandit latency. So then we should provide enhancement for the data plane. But the guarantee, yeah, as just we discussed, we didn't think the guarantee over the latency is just in the forwarding sublayer. Maybe we will provide the enhancement for surface sublayer, but it's not sure. So for now, we from the working group, we just retrieve and consensus for queuing-based enhancement. So we provide some queuing-based mechanisms. Then, so this draft, we propose some common data field for the enhancement, including the deterministic latency and including the queuing-based information. And then we can apply the common data field can be applied into multiple networks encapsulation, such as MPLs, IPv6, and SRH. So last slide, please. So we made some discussions on the mailing list recently about the queuing-based information. So from my understanding, the enhanced datalet we said is we should provide the packet treatment for the enhanced datalet, and then what's the packet treatment we should do the enhancement for the packet treatment, and the packet treatment is we should indicate the behavior for the packet. So we proposed the deterministic latency action and the type, and to indicate the behavior to guarantee the deterministic latency. So but we proposed there's some policies to the queuing information. First is the information must be generic and to cover all the queuing mechanisms, cover all the information. And the second one, the information, the metadata must be simplified, and we should carry only the information that must be carried into the packet. For example, the information that should be used in a communication between the nodes, and which information and which queuing mechanisms we just consider now. I've listed the current 4 queuing mechanisms proposed in the working group. The local deadline queuing-based queuing information proposed in SRTSN, and the deadline-based queuing information just we discussed, and then the 10th node queuing mechanism which could carry the 10th node ID, and the cycle-based queuing mechanisms we discussed more often to carry the cycle-based information. So this is what we proposed just now. Should carry the information in the packet. So we can discuss more in the mailing list. And then we do some discussion whether or not we can reuse the DSCP or the queuing information directly carried in the packet. So we also discussed that on the mailing list. We proposed the pros and the cons. Pros is that the DSCP is very easy to change and reuse, and it's easy to standardize. I think, but maybe the value is not very sufficient for the queuing information. So for now, we are the same proposal with the Xusong that for IPv4 and the traditional MPLs, maybe we could use their existing fields, and for IPv6 and the MPLs or MPLs, new MPLs or the SRH, we maybe use the commented field. So last slide, please. So we proposed the common data field for enhanced datalet, and we proposed a datalet common header. The common header, I think, is optional. If we will propose another functions or other enhancement in datalet, we more than one, and then we maybe lead a common datalet header. And just for now, we just retrieve and consent to propose deterministic latency information, such as the queue information. So we proposed just one option, the deterministic latency action option, and we defined that into the option header and the option data. And the option header we propose the type, and the type may be the behavioral type to indicate the surface levels or surface types, and the queuing type to indicate the queue information, the queuing mechanism, specific queuing mechanisms. So the option data is maybe optional to cover all the queuing information. Next slide, please.
I'm sorry, you have to wrap up now.
Oh, okay. So the encapsulation we can discuss in MPLs, IPv6 and SRH, and our last slide steps is we will follow the resulting and follow the enhanced statement for the terminologies or queuing mechanisms, or the information must be carried, and we also follow the requirements first. So we will do more discussion, continue to do more discussion on the mailing list. Thank you.
Thank you very much. Clearly, there's interest in doing some additions to the data plane to support what's happening on the queuing side. We'll have to make sure that those discussions can proceed in lockstep. Kihan?
Thank you, Chair. So I'm Kihan Yao from China Mobile, and today I'm going to share a draft about VPFC planning scheme based on VPFP in scaling DETNET. So it is a solution of DETNET controller plane. So next slide, please. So as we know that CSQF is effective for bounded latency and jitter, but the prerequisite of CSQF is that the queuing resources do not conflict. And also in scaling DETNET, there might be some more complex situation that you can see that on the right side, there might be some nonlinear topology which will make the queuing resource collation problem more difficult to solve. So we need to think of a effective way to solve the conflict problem in the large-scale DETNET. And so intuitively, two approaches might be solved. The first one is to fix the time slot at the head node and then change the mapping function. And the other one is to fix the mapping function in on the path and then to change the time slot at the head. So for the first one, it may maybe have more higher successful rate for planning, but it may incur some complexity to incur some overhead. The first one maybe because it needs to store the mapping relationship flow by flow, and it will incur overhead to both data plane and control plane, and also on the same physical path for the a flow it might take up multiple cycles. So multiple packets belong to the same flow may have different transmission delay, and also the resource allocation on intermediate path may not be guaranteed. So we try to solve the problem from the second approach, that is to fix the mapping function and then change the time slot at the head node. So next slide, please. Our solution is to realize a VPFC planning. So here are some basic terminology. So VPFP is the virtual periodic forwarding path. So in the forwarding path, the virtual path forwarding based on the cycle, it's based on cycle and the mapping relationship between cycles. And in each segment link in the path, the mapping relationship is a scheduling cycle of the outbound interface of the upstream node and the scheduling cycle of the outbound interface of the downstream node. And next slide, please. And VPFC is virtual periodic forwarding channel. It's based on VPFP, and because VPFP is a path that carries the VPFC, and VPFC has the following characteristics. And VPFC ID is an indicator that uniquely identifies VPFC within the same DETNET periodic forwarding domain. And it also carries some cycle info. The cycle info contains the scheduling cycle and the resources corresponding to the scheduling cycle, describe the bandwidth and periodicity characteristics of the VPFC. And next slide, please. And then we build the mapping function between the upstream node and the downstream node. And when we change the cycle selection on the ingress PE, that is a head node of the change the time slot at the head node of the entire topology, and it will make all the cycles selected along the path chain, which gives either way to solve the cycle confliction. Next slide, please. And also we make some resource quantification to make the resource allocation more accurate. And next slide, please. And you can see that many cycles have more accurate resource planning based on the resource quantification method. So yeah, next slide, please. Here is the overall processing scheme of this VPSC planning method. I will not go into details because of the time limitation, and I will quickly summarize about the advantages of the second approach, because we try to, that is to pick the mapping function and then change the time slot at the head node. So it might have it will achieve stream aggregation through different VPFPs to reduce complexity on both that plane and control plane implementation, and also on the same VPFP, the intra-domain transmission delays of different channels will have the upper limit, and also we fully consider about the case of insufficient resources in a single time slot, and packets will not cross any cycles, and we can build that the multiple VPFPs over the same physical path. So this is the overall solution of this overall solution, overall process introduction of the solution. So welcome more discussions and questions.
Xuesong from Huawei. I just one more comment about, I noticed that this document is standard track, but I go through document, it kind of involve a lot of implementation status, which also give some label on it. It is informational. So I suggest the authors to consider to change it to an informational track.
Yeah, thank you very much. The current draft is really, is long, so we will consider your opinion. Thank you very much.
Yeah, I'm Chuan Sheng from CT. Quick comment is that I noticed you propose a good implementation for the queuing-based configuration model, but you just focus on the cycle-based queuing mechanism. So I suggest you to cover all the queuing mechanisms in the data model.
Thank you very much. The current solution is based on, you try to solve the problem of CSQF, and we'll consider about your suggestion in the future work. Thank you very much. Any other questions? So maybe we can talk about on mailing list. Thank you very much.
Yes, thank you. Carlos?
All right, so this is a new attempt, food for thought on how to maybe start assessing the different mechanisms that we have or will have for the data plane. Next slide. So I was thinking that ideally, I'm a customer and I want to see what a router is doing, and what I get is a spec sheet, and maybe even for the technical customers a little bit more in detail. And then, I can compare the stuff. So how would I do that for our DET network, right? And the idea really is to arrive at something like a spec sheet with the different criteria, right? That are explaining the properties of the algorithm so that they can be compared. And then I've got an example spec sheet for one method, which, as you can guess, is the algorithm that I've been trying to write down, TCQF. Next slide. So I let out all the explanations, obviously, which are in there. So every line is one criteria. So the first one, latency guarantee, right? So is there any, well, given that we're right here now working on them, there should be, so bounded or heuristic. So Jakob-Stein was proposing that we should also have heuristic ones. So far, I think all the ones that are currently actively pursued are bounded. The hop-by-hop jitter bounds, nice marketing terms, or more explicit description, in time, on time. You know, in time would be as soon as possible, right? The network load is low, then the packet is forwarded without any queuing delay, and the on time is you're exactly always arriving at the bounded latency or close therefore. Network applicability, so maybe a coarse categorization, which forwarding plane would it work for? IP, IPv6, MPLS, maybe others, beer, right, multicast, or a subset thereof. Is it intended for really high-speed networks? I think right now most of us are looking into these high-speed networks, but that doesn't mean for the overall evaluation of forwarding plane algorithms, like even the existing ones, that we shouldn't also capture that. Yeah, they're typically bounded by, you know, not wanting to go further than 10 gigabits, which is, I think, what we're seeing in TSN. Does it require a new packet header over the wire? Yes, no, or optional. What are link and jitter requirements? So are there any bounded latency requirements for the links? And that, for example, is the case in TSN CQF. The latency is a bound, or else that their scheme doesn't work. Jitter requirements for wireline links and for radio links. I've separated that out because I think most of us have only looked at wireline links. I guess when we want to talk to mobile networks, they may also ask applicability across radio, and we may just not have thought about it. And then is the algorithm asynchronous, yes or no? Which basically means then we're getting to clocking. And the way I could have, the best I can capture it right now is the maximum time interval error between the clocks and what impact it has on bounded latency. Next slide. So the traffic model of the flows in terms of defining, you know, for how the traffic can express their characteristics. The forwarding model, and obviously for TCQF, this stateless method without per flow information is important. And then the algorithm parameters and mechanisms. The calculus, right, is the calculus for the mechanism available? Is it published? And then also, you know, is it linear insofar as that we can calculate it independently for every hop, independent of the others, and then just add up, for example, the latency. And then the packetization, right? Compatibility with the hop-by-hop source routing, SRMPLS, SRv6, for example, end-to-end packet header requirements, right? So something that doesn't change across the path when it gets longer, and as well requirements where, like, you know, the steering, which where the header gets longer, the longer the path is. Next slide. And so this is kind of how the spec sheet would look like for TCQF, right? Bounded latency, hop-by-hop jitter bounds, it's on time, so almost no jitter, and the jitter is 2 times the cycle time t. The intended applicability, yep, all the forwarding planes. Is it for fast networks, 100 gigabit and faster? Yes. Does it require new on-the-wire packet header fields? No, because we are very confident we can use a DSCP, and not EXP field. Greg is going to kill me. I'm always also remembering. It's in the draft, but I always only remember EXP, right? So the latency requirement for the links, other than CQF, the link latency and jitter requirements are, it can arbitrary link latency, it can arbitrary jitter, obviously at the cost of higher latency. And is it asynchronous? Nope. Does require a clock, and what's the impact then on larger MTIE of the clock? Well, that translates into higher latency. And the level of detail, whether this is good enough or whether there needs to be formulas or something like that, obviously is the next interesting step to talk about, if we would agree that, you know, this type of spec sheet and criteria would make sense. Final slide. Traffic model, right? Bits per cycle, time t for a flow. The forwarding model, is it stateful? No, so it is stateless. What are the algorithm parameters, right? So we just require a mapping table for the forwarding. What's the calculus? Is it published? Yes. Is it linear? Yes. It's per hop calculated. What's the hop by hop jitter bounds? Same as the end-to-end one, right? Doesn't change anything. Packetization, yep, meant to be able to work together with all the forwarding planes we think of. What's the end-to-end packet header requirements? 2 bits, right? 3 cycle values. And then nothing on a per hop basis purely for the mechanism. And I think that's it. Next slide. I think there's just a summary you can read for yourself. Greg.
Okay, if chairs agrees.
Yeah.
Thank you.
He's got 40 seconds.
Okay, great. Greg Mirsky, Ericsson. I think that you just misspoke. That you said that in uncongested, over provisioned environment, there is no packetization delay. I think that probably it will be more accurate to say there is no packetization jitter. Because it basically, when you uncongested and over provisioned,
serialization,
you
there's
don't,
the serialization
right.
latency. There is no queuing. Can we call it queuing delay? Yeah. So
well,
right.
the queuing delay, though, yeah, there is no queuing, but there is no delay variation. So basically, latency exists.
Yeah, please take that to the list. I think you are highlighting the importance of terminology, and that as we go forward with the queuing mechanisms, we make sure we have common terminology. Something else to add into the criteria. Shuyan?
Okay, hello everyone. It's Xuyan from ZTE. Okay, this draft is about the young data model for DETNET mapping with network slice. Okay, please, next slide. Next slide. This draft introduces the use case for DETNET applied to network slice and its related requirements and its corresponding young data model. Yeah. For the use case, it refers to the RFC 8578. There are 2 use cases. First one is about non-DETNET aware slice, and the second one is about DETNET aware slice. The DETNET for the first one, there's no DETNET flows in the slice, but because slice can provide such as low latency service, time-bound delay, time-bound service, and big bandwidth service. For the low latency service, it can be considered the deterministic service. So, but there's no DETNET flows transported in the network. For the second one, DETNET aware slice, you can look at this figure. It shows an example for the low latency service overlay NRP. The NRP is a solution to provide to realize network slice. And through NRP, it provides the adequate or necessary network resource to its its overlay service. Okay, so next slide. For this use case, we consider the constraints for DETNET and the benefits for IETF network slice. And the benefits for DETNET applied to network slice through network slicing technology, it can provide flexibility of resource reservation and service quality customization to DETNET service. And through the help of convergence of network slicing, it can improve the service, the resource service level from the best effort quality to closely guarantee. For next slide, please. To resolve this use case, we use .NET mapping with IETF network slice. We use mapping function to realize this use case. The mapping will revolve two factors. First is about the .NET service sublayer mapping, and the second is for .NET forwarding sublayer mapping. And for the service sublayer mapping, we need to first to abstract .NET latency sensitive service parameters, and then map to network slice slow slay template. And for the forwarding sublayer, it also needs mapping to realize path selection and resource reservation. And this function will be achieved through the NRP policy. Next slide. For the Young model, there are some considerations. We will use a reference, the existing Young data model as reference. It may include .NET Young, and at IETF there's network slice Young as service Young, and there's also need to refer to the NRP Young. And based on the reference, we also need to create a new .NET network slice mapping type Young to realize the .NET service mapping with IETF network slice. And in this document, we propose these two Young model, and to realize to realize the use case, and the augmented .NET Young model will include the service sublayer, to realize this mapping function. Okay, next slide. For the recent updates, there are some updates such as problem section is removed, and the use case is added and modified, and some Young errors are fixed. Next slide. For the next step for this draft, we will update based on some comments that the question are resolved or received, and to address some question. And we also would like to look for some co-authors to work on this draft. Okay, thank you.
Great, thank you. No comments? So you presented this before. I believe we talked about making sure there's good alignment with the work that's going on T's, particular on identifiers. I would suggest to send a message to the T's working group, letting that working group know that this work is happening here, and is being discussed here.
Okay. We will go to TSWG and ask for some comments.
Exactly, just to be aware that this discussion is happening inside .NET.
Okay, thank you.
Thank you very much. And with that, we're going to move to the last presentation, Kieran.
Hi everyone, I'm Kiran. Next slide, please. So this is a 0.0 version of our draft, and it is an output of some simulation or the POC we've been doing with process automation in industry control networks. So we came across some limitations, and I wanted to share what those are. So we were building this platform, and next slide, please. Go to this one. Yeah. So how we use industry process automation in the industry. We had TSN networks, and you can just go ahead and configure the devices there, and they interact whatever information, process command information. Then DetNet came, it's pretty much the same, that you get better scalability, but you still have to configure devices in terms of flow, ID to interface between controllers and field devices. So now if we look at a more progressive, optimistic way, that we have a cloud-centric behavior where controllers could be somewhere in the cloud because they need better compute and better storage mechanisms and have to manage a lot of field devices, then controller-based configuration mechanism does not work there. So we were looking for a different way how my end devices or controller can interface with the deterministic network. Next slide. And just we made few observations that when we generalize this type of model, we can see that our components are quite simplified. Our end systems can be classified in terms of controllers and field devices. The interface is going to be quite straightforward because the roles these actuators or the sensor perform are quite limited. Even if you go from one industry vertical to the other, those that behavior does not change. And what we are looking for is a communication between a controller and a field device pair. And it is slightly different from what DetNet does today, which is based on flow IDs. Next slide. And this is, I'll let you read offline. It is about the traffic patterns, how controllers will interface with the field devices. Some of the things we want to worry about is how control loops will be implemented using DetNet, how periodicity is established. So these are the things that are already being done in terms of queuing, scheduling. We just want to figure out how an application can interface with DetNet to provide these mechanisms. Next slide. So what we are focused on is if I have an end system, which is definitely going to be IP based, and if we are in the right direction, it is very hard to get extensions with IPv4. So we would like to rely on an IPv6 based system. So we came up with mechanisms so that now you split your DetNet architecture in two parts. So we only focus from end system to the relay node, and then how you configure your DetNet, it's up to the service provider or DetNet service provider. Next slide, please. So these are some of the considerations that most of the discussions I've seen here or observed are based on how an operator will deploy a DetNet system, but it's not talking about how application can use these data planes. For example, if it is MPLS, then my end device controller has to know that there is an MPLS network in the system, but it doesn't work very well with the cloud-based environment. If I move my application from one system to the other, let's say from MPLS to SRv6 or something else, then I will always have to continuously make changes in my applications, and that's not very suitable. And we also need a more practical way for applications to interact with the network. You don't want applications to realize, okay, this is the queuing model I want to use. This is the type of algorithm I want to use in the network. You want these things to be, you don't want applications to worry about these things. And then split traffic flow is another problem, that if I go from my ERP application to controller and all the way down to the device, I'm losing out on end-to-end process automation. So we would want to eliminate that type of split mechanism and then support different type of traffic patterns that I mentioned earlier. Next slide, please. So this is what I came up with, that how about the easiest way an application can interface with the network is using native IP support. And we can come up with an extension header that talks about, okay, these are my requirements from an application perspective. For example, if there is a fault on a particular field device, I'm just going to send an urgent message that please send this message urgently over your DetNet. I don't care what kind of queuing mechanisms or what kind of scheduling you use in your network, but I want this message to be treated as an urgent delivery method. Similarly, if I have different kind of actuators in the system, and each actuator may have different kind of bounded latency requirements in terms of when the command can be delivered. So I want to provide my latency spec to the network that this is the information. Again, I don't care what kind of mechanism you use. So this is what we are exploring right now, that can we support an extension header that encapsulates application to DETNET interface. And I would like to get work groups feedback on it, that is this the direction we should take? Should we go ahead with this? Does it fit in the group or not? Next slide is just covering that part. This is my last slide. I'm just looking for the feedback, how to go about this work.
Okay, thank you. Dan?
Yes. Dan Bogdanovic. So I agree with this, that the application should not have to understand the intricacies of DETNET services. Full agreement. But the application design is not black and white. It's sort of where the action is in the cloud. The industrial real-time operating, the industrial application that are using real-time operating systems, they are being designed in a more hierarchical ways. If we take an example of autonomous car, a lot of computational things is done at the car.
Mm-hmm.
And the global context is updated occasionally, but a lot of computation is done at the car.
Yeah.
And then in industrial environment, with some of the robots, they work like swarms, and they get the global context computed somewhere in the cloud. They get it to a local application controller that builds it up at, that controls it at a swarm. So in this presentation that you did, you said like, oh, here's the cloud, here's the host, but it is not so clearly delineated. It is much more granular. And then the DETNET would be just applied between the local application and the devices that are under the control of that application.
I agree with you that there are so many different kinds of scenarios, and DETNET may apply to only certain set of cases. But specific scenarios I'm looking at is something like I have multiple sites of factory floors, and I want my edge cloud to control those two sites together. And I want to control some kind of supply chain. So for that, I don't need DETNET to be local. I can actually extend it to my edge cloud environment.
So this is actually a super interesting discussion, and what you're presenting here is a little different than the data plane changes that were in slots earlier, where you're thinking more about from the application side. It's a good discussion to have. It's a new discussion for the working group, so it's really good. But we're actually a couple of minutes over. Really appreciate everyone sticking to time and giving everyone an opportunity to present their material. Look forward to really more good discussion on list and on these open meetings. Look at the list. The WebEx is already announced. So continue the good discussion, and we'll see you in San Francisco.
Welcome.
And thank you for everyone online.
Hello.